Okay, so now you have a pretty good grasp on where these trig ratios come from and how they relate to the unit circle and how we can use similar triangles to solve for the sides of right triangles. Let's quickly review our system here. So here's theta. We're going to put theta here. If that's the case, this becomes my cosine of theta, which we now know is our adjacent side, A. Our side across from it is our sine of theta, which we know is our opposite side. And then we have our hypotenuse, which in the unit circle is 1, but in any other triangle, it's not going to be 1. And then what if I asked you to do a problem, you would draw a similar triangle and you would get these things all set up. Well, there's actually an easier way. If you rework the proportion, if you take the proportion that we got from the similar triangles and you do some algebra on it, just kind of manipulate the equation, what you end up with is actually the following. You end up with the sine of theta is always going to be equal to the length of the opposite side over the hypotenuse. You're going to find out that the cosine of theta is always equal to the length of the adjacent side over the length of the hypotenuse. And you're going to find out that the tangent of theta is equal to the length of the opposite side over the length of the adjacent side. And so we know now this is true all the time. Sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. And we have a little saying to remember that. So, ka, toa. So, sine is equal to opposite over adjacent. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. SOHCAHTOA. Okay, and if you went home right now and asked your parents, do you guys remember SOHCAHTOA? I guarantee you they'll remember. They may not remember exactly how to use it, but they'll remember it. So let's write that right here so that we can refer to it. Okay, so how does this work? So the first thing we need to do is when we're given a problem, we need to identify where our theta is. It's down here, and let's label our triangle. The side across from it, where x is, that's going to be my opposite side, and this is going to be my hypotenuse. Notice that the adjacent side is not labeled. So this problem has to do with the opposite side and the hypotenuse, and the only one that has opposite and hypotenuse is sine. So now I can write it down. Sine of theta equals opposite over hypotenuse. And now I just need to plug in. Sine of 36 equals x over 21. And to make this a proportion, I just put sine of 36 over 1. And now we proceed the same way that we did in lesson 1. So I'm going to do sine of 36 is 0.5877. We're going to put that over 1. That equals x over 21. Cross multiply and solve. X equals 21 times 0.5877, which is going to be 12.3417. Let's round to the nearest tenth. X equals 12.3. Okay, let's do more. So again, here's my theta, and I want to label my triangle. So in this case, I've got the side across from it is 5, and the side next to it is x. Next to it is adjacent. So now let me go back to SOHCAHTOA. Which one has opposite and adjacent? TOA. So that's tangent. So I'm going to have tangent of theta equals opposite over adjacent. Tangent of 41 over 1 equals My opposite is 5. My adjacent is x. Let's figure out what tan 41 is. Got 0.8693 over 1 equals 5 over x. Cross multiply and solve. 0.8693 x equals 5. And then divide both sides. 5 divided by 0.8693 is going to be 5.7518. Round to the nearest tenth in this case, 5.8. Okay? So you start by putting yourself on theta and identifying what sides you have labeled. The side across from it is opposite. The side next to it is adjacent. And then we always have the hypotenuse. Figure out which trig ratio you're working with and then proceed from there. Now, the other thing I want to cover in this unit is we can actually solve for angles too. So take a look here. Notice that in this case, I've got the sides, but I'm missing the angle. So these problems start the exact same way. This is my theta right here. So what sides do I have? I have the side opposite it, which is going to be sine, and I have my hypotenuse. So if I go to SOHCAHTOA, opposite over hypotenuse is sine. So we're going to start the same exact way. We're going to do sine of theta equals opposite over hypotenuse. Plug in. Sine of x is the angle this time, equals 36 over 47. Now, to get x away from sine, to get x by itself, which is what we're doing when we solve, to figure out what that angle is, what we're going to do is we're going to use inverses. So this is where sine -1 comes in. Whatever I do to one side, I have to do to the other. Now, this is part of the calculator skill. We'll get to it just a second here. So first of all, on the left-hand side, inverse sine and sine, that's how you say this, inverse sine and sine undo each other, and I'm left with just x. On the right-hand side, I need to go to the calculator and do the inverse sine of 36 over 47. Refer to the calculator video that I created in terms of how to use the calculator here. But inverse sine of 36 over 47 is going to be 49.9922. If I round to the nearest tenth here, that's going to be 50.0 degrees. 50.0 degrees. So the only time that you use these inverses is when you're trying to find the angle. Otherwise, you use regular trig functions. Let's do one more. Okay, so in this case, my theta is down here. Let's label. I have the side opposite it, and I have the side adjacent. If you look at your SOHCAHTOA, the only one that has opposite and adjacent is going to be tangent. So this is going to be tan theta equals opposite over adjacent, plug in. Tangent of x in this case is 10 over 5. And now I have to use those inverses. Both sides. So that leaves me with x equals the inverse tangent of 10 over 5. Go to the calculator. Inverse tangent of 10 over 5 is going to be 63.4349. Let's round to the nearest tenth. X equals 63.4 degrees. So now you know a quicker way to use the trig ratios to solve for missing sides, and you know how to solve for the missing angles using inverse trig functions.